Section 5.1 is a discussion on sets. So a good place to start would be with a definition. Here's how a set is defined. It's a well-defined collection of distinct objects. Now, by well-defined, that means we actually know what it is. And it's a collection of distinct objects. So the objects in our collection have to be distinct. They have to be distinguishable from one another. So right here I've written 3 collections. Now, a set is typically put inside of these curly braces, and we usually name it with a capital letter, although you can name it anything you like. I'm just using capital English letters. So the collection A, now look at this. Is it well defined? Do you know what these are? Yeah, these are integers. I can distinguish them. This object is different than that one. I can distinguish them just by looking at them. So this collection here is a set. What about the second one here, B? This is the set of, here's how to read this, the set of all numbers x. I know I'm dealing with numbers because I looked over here and I see they're numbers. So this is B, it's a collection of the set of all numbers x such that this condition holds. So if it's going to be in here, it has to meet this condition. And what meets this condition? 4 and negative 4. So I could rewrite this set just like this one right here. Right? So set B could be written just like that. And what do you think? Are these well defined? Yeah, you know what they are. They're positive and negative integers, and I can distinguish one from the other. So this collection is a set. Now what about C? Well, C is the collection of what? All happy people. This is not going to be a set, because what do we mean by happy people? Is that well defined? You know, do we all agree on what a happy person is or is not? So this is not a set. It's not a set because we don't know what a happy person is. That's not well defined. Sometimes I want to talk about set membership, so I might write something like this, 3, and this symbol right here, and I could write the set, like 2, 3, 4, 5, 6. Now what this says is that this number here is an element. You might think of it as an E for element, but it's not really an E, it's not an epsilon, it's kind of its own symbol. But 3 is an element of this set, and I know it's true because, do you see it in here? If 3 is an element of this set, to be true, this has to be in here, and I can see it. But what if I wrote this? 7, I can write it, 7, and I wrote this, 2, 3, 4, 5, 6. What would you think? True or false? Is 7 an element of this set? Well, I look in here, and I don't see a 7. So 7 is not an element of that set. So this statement here as it's written is false, but I could make it true if I just do this. Put one of those negation signs through there. So now this says 7 is not an element of this set. And I know it's true because I look in here and I don't see a 7. We can operate on sets. Suppose I have this set here, A. Now I'm going to change it from here. Suppose this is set A. 1, 2, 3, 4. We might as well use the same one. So there's set A, and set B, why don't we make set B like 2, 4, 6, 8, 10. Now what I could do is I could union these two sets together. Now union means just to take everything in one set and everything in another set and dump them all into this new set. So I might be doing like this. Here's A, here's B, and then here's this new set that I'm going to call A union B. Now this is it's kind of like this. It's hard to draw. You can do it in a book nicely because you got some typesetting, but it's kind of a U for union. So what we're doing is we're taking everything in here, right? So I've got some things in here and some things in here, and I take all of these, put them in here, all of these, and put them in here, and I call that new collection A union B. And this symbol right here is kind of like a big U. It's not really a U, it's its own font, but I read it as A union B. And for our two examples up here, for our two sets here, if we write A union B, well, it's this new set. So what do? Like right over here. You take everything out of A, put it in here. So what's in A? Well, 1, 2, 3, 4. So what goes in here? 1, 2, 3, 4. And then you take everything out of B and also put that in here. But now keep in mind that whatever goes in here, these have to be distinguishable objects. They all have to be distinct. Now when I start putting the numbers from B in, I see I already have a 2. I already have a 4, so I don't need to write those again, because I can't distinguish this 2 from this 2 or that 4 from that 4. So what else am I going to put in? A 6, 8, and a 10. So I'll get 6, 8, and 10. So the union just consists of these numbers now. Everything in A combined with everything in B, so I just get 1, 2, 3, 4, 6, 8, and 10. Now the intersection, what I'm going to do is just take the elements that are common to both sets. This is the set of common elements. So maybe I could draw it like this. Okay, here's set A, here's set B, and set A has some things in it, and set B also has some things in it. So here's set A, it's got all of these in it. Here's set B, it has those in it, but there's two things in common. So this little part right here, I'll draw it in red here, this part right here, that would be the intersection. So the intersection is exactly what it says. It's the intersection of those two sets, the set of common elements. So using our two sets, I would write it like this, A, and you just turn the union sign over to intersect. So it's kind of like a big one of these. A intersect B is the collection of what's common. Now look at our two sets back over here. What's common? Well, 1's in A but not in B. So 2's in A and B, 4 is in A and B, and that's it. That's the only two things that are common. So 2, 4.